Hi, welcome to another video on my monorail made of fischertechnik, controlled by Robo interface and BeagleBoard Classic, running Linux. Last time I rewired and checked my program and found out that a lamp was defect. That was this lamp, which signals the end of the track, and according to measurements the wiring is okay and this lamp isn't. So I took out the lamp and it looks quite burnt. So to be sure, I checked it and compared it with another lamp, and this one is quite bright, and upon checking it revealed that it was quite okay. So right now I'm putting this replacement lamp on its place. And then the lens cap on its place to make sure nothing else is being eliminated but the sensor on the other end, which is this one. So what I'm going to do now is start the Diagnostics Software and see if this lamp indeed indeed does what it should do. So let's see. Opening the interface. So now I can select the output on which this lamp is. And I have to check, of course, that all the wiring is in place, and yet which wiring is it? That is right now, by the way, I changed that last time to check. So I should now check output 6. Does this work? Not really. Let me for security check anything else. And put it back where it belongs, because I tested this lamp and it was clearly okay. And with this you can see that whatever you try and test, something always goes different than you expect it to go. So now it is on output 5. Let me check output 5. And there you have it. Output 5 has the correct wiring. Now it eliminates this one. So for completeness, let me check this one as well. Let me move the carriage out of the way. This one is from output 5, 4, 3 or something. Here it goes. And the interface tells me that input 7 is illuminated, so that is great. And for the other, input 7 and 8 are both working. So that demonstrates that everything is alright. Now I can go on with the programming. So, as you can see here, outputs 5 and 7 are on. They're on, let's say setting 4, output 4, level 4, whatever. And you can see here with the input that the output is received by the sensors. So that is a very good point. Now, in order to test the software once again with working sensors this time, or input receiving sensors, because the lamps work, I have to close the interface. And now I can see if everything works. In the meantime, I did let me explain this. I tried the GUVC view program, which is lightweight program to use a webcam for a camera, so I can have image inside the screen. And I did so using the Raspberry 2. I did so previously with a BeagleBoard, other model BeagleBoard. Unfortunately, this model that I'm using, the Classic revision revision C4, is not doing well with this program, so I can't use it. Anyway, let's for now start the software. And what I see is something weird. Let me see it. Let me start it again, because this input is receiving, but this lamp is not sending. This lamp isn't doing anything in the software, so it won't detect. So now I have to find out why, and I have to look for output 5, and as you can see here, set output 5, strength 6. Where do I have output 5? That's a very good point. Where do I have it? It seems that I only have it right here. And it sleeps for 2 seconds. Ouch. Let me run it again. But in the program it doesn't, it's not doing anything. Nothing at all even. So the problem is, how do I even start it? It has to sleep for a while. because without sleep it just goes on and immediately off, and there's no mention of output 5 anywhere else. So that's a good one. Well, the point is that if I look at here, this is output 7. Where is output 7 set? That's a very good point. Where is output 7? Or am I wrong? Let me see what else, because this is something odd. This is the control lamp, and the control lamp burns in a wrong moment, at the wrong moment, but at least it burns. And for the rest, I don't see it, which is an ouch. So let me put a set output 7, and this is very strange. This shouldn't be happening. Let's test again. What will happen now? Now both are burning. Now actually both are burning. That being said, the carriage still goes back and forth between the sonar and the first lamp. So I have to check once again. One obvious way to diagnose is, of course, apart from this piece of software, print statuses. So that is what I'm going to do. And then of course I have to put in each statement where it is from, because those are different ifs. So I say D2 this, and D2 larger than 5 if 1. Sounds rather cryptic. Oops. And this is the if 0 statement. Then here not D8. And this way you can set everything you want. No, I have to take this one. On the other hand, I have here ifs, so let me take this one. And then it is D7. if 1, and once again the 7 if 0. So let's see what this gives. Larger than 5 is 0. Okay, I stop for a moment because what I see is that the direction status is 0 everywhere. And that is odd, because if it goes towards one side, towards the end of the track, the status should be 1. So how come it isn't 1? And you see here the digital 8 is 1, which is logical, but it doesn't explain why the status is like this. For instance, D2 is smaller than 5 when it is as now at the side of the sonar. However, in here I don't see this smaller than 5. I don't see that. I only see larger than 5, which is quite odd. Very odd actually. And looking at these status lines prints, I should change them. So now it says something different than it should say. This is correct. So here this is all correct. This has to change too. So now things are better, less confusing, but that doesn't change the working. So let's try once again. And once again the status is completely 0, and it is now at the sonar side, but that means that D2 is smaller than 5. I'm stopping it, and why doesn't it get there? It even has to print what the distance is. So let me do the same. Here I copy and I put it here, and I say okay, whoops, larger than 5. What is the distance? Oops, let's try again. That is to say, alright. Now I can. (11). One thing's for sure, this distance is not 11. Now it gets smaller than 5. Yes. It had to interrupt, so D7, the status D7 is 0. Where is that set? D7 here. Okay, let's interrupt. So what has happened? Here it finally says distance is 2. Here the distance is 3. Then D2 smaller than 5, status gets 1. Yes, status gets 1. So the direction is reversed. It gets larger than 5. Then if the status is 1, which it is, that is a nice one. I have to change the algorithm, because this, or more appropriately, let's see, if it is not digital, if this is not at, which means that the carriage is actually at T-digital 8, it is, in this case it is blocking the light, which is still larger than 5 centimeters. So that's the point in this algorithm. I have to change that. That's a very nice one. Good discovery. Yes. So let's go change the algorithm. So actually it turns out to be quite simple. I have to indent this if, and I have to indent this if. And then I can comment out these two, I think. So let's just try this. Comment out. Then this one. Indent. And this one, which is the middle lamp, indent. So now these are out. This is part of the D2 loop. The D2 greater than 5, larger than 5, and this is also now part of the D2 larger than 5. Are these really doing what they should do? I think so. So let's see and try and see. Well, that's the first oops. It doesn't get beyond the middle lamp. and I don't really know why that is. Now it gets beyond it. For the first time it did the complete trajectory, as you can see. The only thing is, I have to hold the wire. And come on. Nope. There it goes, the complete distance. Yes. And there it goes, the complete distance again, and it goes back. So this is very interesting to see, see it cover the complete thing, and you see it from. And now I have to enable the touchpad. So let me see if this works. Yes, it works. So now you see actually the distance getting larger and larger, reaching 14, which is maximum. And here it very nicely says, alright, 14 here, distance is larger than 5, this is larger than 5, and here 1 and 80 is 0. Here the direction gets changed, and here you see D7, if 0 is 0, then go all the way down, which is exactly what is supposed to be. D7, yeah, if not D8, then status is 0, and here D7 middle lamp, if status is 0, just continue. Now the sleep is important as well, because if you do it too soon, the motor stops. But right now it is fine. For the first time, because I have included the not digital 8 and digital 7, which is by the way not logical, because it's always the 7 unless the carriage is there, in which case it is not digital 7. So this good result may have been a coincidence. So let me change it to D7. So as a conclusion of this video, I'm gonna show exactly how it happens, how it should happen anyway. And what you may notice is that I hold the wire. Reason for holding the wire is that it may get stuck in these grooves, so then the carriage won't go anywhere. A little bit of help. And then there's a timing. Oops, why is that happening? I'm not sure why this is happening. That was too much of a push. Anyway, as you can see, in general, it just works very nicely. As I said, in general. What I still have to solve is the wire. I'm not satisfied with this solution. Not satisfied at all with this solution, because somehow I feel that I should put the wire somewhere along the rail to be dragged along. So I think I should use something like the wheelbase of this, and then see how this ends up. So now I won't I will have to let it loose, see what happens. It works, but then again, this is something I didn't expect. But anyway, it's a good solution. The algorithm has improved, works good, and that's it. So thank you for watching. If you like my videos, please subscribe to my YouTube channel. If you like my videos, and please consider to support my blog by allowing advertisements in between the video segments. If you don't want to do that, please visit my website, which is listed under this video, and see there for details for another way to support my website and blog and videos. And this is still to be continued, because I have more plans.